The reference angle is the angle between the terminal side and the x-axis. It's always positive, and it's always less than 90 degrees or 2 pi radians. If you are in the first quadrant, you have some random angle in the first quadrant, your reference angle is right here, the same exact angle. If you're looking at some angle in the second quadrant, your reference angle is right here, between that angle and the x-axis. If you have an angle in the third quadrant, your reference angle is between the arrow and the x-axis, so this would be your reference angle. And if you have an angle in the fourth quadrant, your reference angle is between the arrow and the x-axis right here. What we're going to do is determine the value of the reference angle, or calculate what number that is. So when you're determining the value of the reference angle, it helps for you to know what the angle measurements are at the axes. So if you need a refresher, you start here at 0, then 90 degrees, 180, 270, and if you come all the way back around, you're at 360. Let's do some examples. Find the reference angle for 132 degrees. Well, 132 is somewhere between 90 and 180. Our reference angle is between our arrow and the x-axis. So, to get from 132 to the x-axis, which is 180, how much is between 180 and 132? You could actually calculate that or use your calculator. The answer is 48 degrees. Find the reference angle for 257. 257 is somewhere in the third quadrant between 180 and 270. Our reference angle is between the arrow and your x-axis. So the x-axis is 180 degrees. How much is between 257 and 180? 77 degrees. Find the reference angle for 85 degrees. 85 degrees is somewhere between 0 and 90, so that means it's in the first quadrant. The reference angle is between our arrow and the x-axis, so it's the exact same angle. At the x-axis, we're at 0 degrees because we haven't gone all the way around yet. So how much is between 85 and 0? 85 minus 0 is 85 degrees. In the first quadrant, your reference angle is equal to your actual angle. Find the reference angle for 272 degrees. 272 is a little bit past 270, but we're not quite at 360. Our reference angle is between that arrow and the x-axis. At the x-axis, we're going to use 360 this time because we've completed a whole circle. So how much is between 272 and 360? 88 degrees. If your homework throws in negative angles, as long as they don't ask you which quadrant you're in, you can ignore the negative sign and just treat it like it's a positive, because the reference angle will still be the same regardless of whether you have a negative or a positive angle. We can do one example just to make sure you feel comfortable. Remember, if we're going in the negative direction, that means we go down, so negative 90 is at the bottom instead of 90 being at the top. Find the reference angle for negative 132. This is the same thing as the first example we just did, except now it's negative. Okay, negative 132. 132 is between 90 and 180, so negative 132 is somewhere down here. The reference angle is between our arrow and our x-axis. At the x-axis, the measurement is 180, negative 180. So how much is between negative 130 and negative 180? minus negative 132. It gives us 48. Remember, your reference angle should always be positive, so regardless of whether you ended up with a positive or negative number there, take the absolute value and just use the positive value. Notice this is the same answer we got when we did the very first example with positive 132. Before we do any radians, let me refresh your memory on what the angle measurements are at the axes. So in radians, we'd start with 0. At the top, it's pi halves, or 0.5 pi. All the way around is just pi, or 1 pi. At the bottom is 3 pi halves, or 1.5 pi. And then if you go all the way around, you're at 2 pi. To find your reference angle for radians, we're just going to compare numbers, so 0, 0.5, 1, 1.5, 2. And then our final answer, don't forget to actually include the pi symbol with it. We're just going to work with decimals and fractions while we're actually working the problem. So find your reference angle for 6 pi over 5. All right, well, 6/5 is the same thing as 1.2. Where is 1.2 on this scale? 0, 0.5, 1, 1.5. 1.2 is between 1 and 1.5, so that'd be about here. So we need to compare 6/5 to 1, because 1 is my measurement at the axis. Okay, 6/5 minus 1, you can use your calculator or you can strengthen your math skills and subtract. Make sure you get a common denominator. You should get 1/5, and don't forget to include your pi symbol as your final answer. Find the reference angle for 11 pi over 6. Let's just look at our numbers here. 11/6, type it into your calculator, it's 1.83. 1.83 is between 1.5 and 2. So 1.83 or 11/6 is somewhere in the 4th quadrant. This is my reference angle. I am closest to 2 pi. So how much is between 11/6 and 2? Subtract, you can use your calculator or you can use a common denominator here. 2 times 6. And we're using absolute values because your reference angle is always positive. So my reference angle is 1/6 pi. Find the reference angle for pi over 9. So this is 1 pi over 9. So 1/9 is 0.11. 0.11 is between 0 and 0.5. So this is my angle here, 1/9 pi. My reference angle is between that arrow and my x-axis. So how much is between 1/9 and 0? Oh, 1/9. Don't forget to include your pi symbol. And that's my reference angle. I'm given a negative angle here, but remember I told you you can just pretend they're absolute values here. It's going to be the same regardless of whether this was negative or positive, so I'm going to just treat this as if it was a positive. As long as they don't ask us about which quadrant it's in, we're good. So 7 pi over 11. 7 over 11, type that into your calculator, it is 0.63. 0.63 is between 1/2 and 1. So this is 7/11. The reference angle is between my arrow and my x-axis. So how much is between 7/11 and 1? And I got 4/11. And don't forget to include your pi symbol. Next example, let's go back to degrees, 408 degrees. Oh, where does that fall on our coordinate plane? Because we don't have a 408. If you have something like this that is larger than 360, or in the previous case, larger than 2 pi, then you need to use coterminal angles to find a smaller angle that is smaller than 360. Remember, coterminal angles, you can find them by subtracting 360 or subtracting 2 pi. So that is all we're going to do, add or subtract depending on if they gave you a positive or a negative. So I'm going to subtract 360. You may have to subtract multiple times before you get to anything, but this is 48 degrees. A coterminal angle is 48 degrees, which is between 0 and 90. The reference angle is between your arrow and your x-axis. So how much is between 48 and 0? Next example is the same exact idea. I gave you degrees before we deal with radians. 959 is way bigger than 360, so let's subtract to find a coterminal angle. Okay, that's still way too big, so I need to subtract again. Now finally, this is between 0 and 360. 239 is the coterminal angle, if you remember that word from a previous class. 239 is between 180 and 270. The reference angle is between your arrow and your x-axis, and at my x-axis I am 180. So let's subtract 180 to figure out what the reference angle is. All right, now that we've got that with degrees, let's do the same exact process, but let's do one in radians. All right, 31 pi over 10. 31 pi over 10. If you wanted to just compare 31 over 10, you'd get a decimal that is bigger than 2. So that is telling me I need to find coterminal angles here. So take your 31 pi over 10 and subtract 2 pi. You may need to find common denominators here. 2 times 10 is 20. So my coterminal angle is 11 pi over 10. 11 tenths is 1.1. So that means I'm somewhere around here in the third quadrant because it's bigger than 1, but not quite as big as 1.5. All right, the reference angle is between my arrow and my x-axis, and at my x-axis the value is 1. So 11 pi over 10 minus 1 pi. Find a common denominator. 1 times 10 is 10. And subtract. Don't forget to include your pi as your final answer because this is reference angles and we're dealing with radians, and radians have pi's with them.